All right, we are live. Hi, everyone. Welcome to another episode of Hoot. With me today, Or Weis and Asaf Cohen from Authorizon. And following up to our OPA series, we are here to talk today about OPAL, that's part of the OPA ecosystem. Or Asaf, why don't you introduce yourself a little bit?
Thanks. First of all, it's great to be here, Yuval. I really love the Hoot. It's great podcast, video blog. I don't know how you call it. And just to give a little bit of background, so my name is Or Weis. My background starts in the intelligence core. I worked a lot in cybersecurity as a VP of R&D. I co-founded a company called Rookout in the production debugging space, and now working with Asaf in the extremely hot authorization space on Authorizon. And as Yuval mentioned, OPAL, our addition to the OPA ecosystem. Asaf?
Hi, so I'm Asaf. I'm Or's co-founder. I'm a software engineer. I've been at a few companies such as Microsoft and most recently Facebook, where I worked on developer tools. And now I'm co-founder and CTO of Authorizon.
So as always, we have our live chat. Feel free to ask questions live and we will answer them live. We do this suit about every 2 weeks. And next week, tune in for the episode about rate limiting and Envoy. So without further ado, let's talk a little bit about the Open Policy Agent, about OPAL. Why don't you give us a little bit of an intro, how OPAL came to be?
Sure. So in general, we're working in the authorization space. Authorization is a huge problem. Everyone's rebuilding authorization mechanisms for their software, for the infrastructure level and for the application level. Up till now, you only had solutions for authentication and you were building authorization completely on your own. Recently, there are new trends, new open source solutions that you can use to build the authorization for your infrastructure and for your applications. The two leading ones, as we're seeing it, is OPA, Open Policy Agent, and also Google Zanzibar. We'll focus on Open Policy Agent today. Open Policy Agent is a general purpose policy engine that uses a specific DSL called Rego, which allows you to write specific authorization code for your application and decouple it from your microservices. So you have a specific layer for authorization that you can change dynamically without having to change your code and vice versa. And that's OPA. And OPA is great. It's highly performant. It's part of the CNCF ecosystem, but it still has some challenges, especially when you take it to the application level. One of those key challenges is keeping it up to date. Currently, OPA expects you to either load data into it or include the data as part of the request that you're sending to it. And in the infrastructure level, like if you're just doing authorization for Kubernetes, that kind of works well because things change at the pace of CI/CD, of deployments. But in the application level or more complex environments, it changes a lot faster. Think about you inviting a new user in an application. You don't want to wait for deployment for that user to get access. So you need something to keep OPA up to date so it will always be aware of what's happening in the application level and above. So that's one problem that we're solving with OPAL. And the other one is just the overall data plane. You don't only have data inside of OPA, you have data across your systems that you might be needing for authorization. For example, if you want to have a policy saying something like only users that have paid for the product should have access to it. The information that for who has paid usually sits today in a service like Stripe or Chargeify. So we need some way to bring data from those services into OPA and keep them in sync. And lastly, just managing the data plane. You have a lot of data now, and loading a lot of data into OPA can be challenging. With OPAL, you can apply sharding. You can essentially divide the different bits of data that you have between different instances of OPA, keep that synced in the background with OPAL, and just keep on sailing as if nothing's different. That's kind of the overall picture.
That's very cool. So what I'm hearing is you're helping to be a better control plane for OPA. You're solving kind of scaling and you're doing kind of integration to get data from other locations.
Yes, and doing that with a real-time component that enables you to sync your application with your authorization layer with OPA. I can elaborate on that maybe a little. The way that works is with a real-time WebSocket-based component that essentially does pub/sub. You can have each, through OPAL, you can have each OPA instance subscribe to update topics, saying, this is the kind of policy that I need, these are the kinds of data points that I need, and only those will propagate into the specific OPA instances. And as I said before, it's asynchronous in the background and real time.
Yeah, all those good words for distributed systems, eventually consistent and low latency.
Exactly.
So good.
Yeah. I think maybe a good thing to do now would be to like see a quick demo of it, just to see how you can set up OPAL. In the end of the day, it's a kind of a client-server architecture that you set next to OPA. And I think that will also kind of clear up the picture and maybe enable more questions.
Yeah, that sounds great. We do demos a lot on this hoot, and the viewers love it. And while you do the demo, maybe kind of talk about the operational aspects of what we're seeing.
Sure.
All right, the floor is yours.
Sure. So let me just share my screen here, and let's talk a little bit about what we're seeing. So basically, as Or mentioned, OPAL takes OPA as an agent that usually is deployed with static policy, and wraps it in a real-time aggregation layer that allows it to be in sync with an application and essentially run as a microservice for authorization. OPAL usually runs OPA for you in the background and syncs the data. So for example, I have an example repository here with example Rego code. Okay, very, very basic RBAC policy, an example data that it runs. And we're gonna use the OPAL Docker Compose playground that comes in documentation and just deploy it very quickly and see how real-time updates look like with OPAL. So let's just do it very quickly. We have this, this one command that runs OPAL on your machine. So you just run a Docker Compose, and we'll wait to see that OPAL is running. Essentially, OPAL comes as a server-client configuration where the server syncs all your agents and pushes updates to the agents, and the clients are running OPA in the background. So let's see what happened here. Essentially, OPAL client fetched data from the OPAL server, and also it runs OPA in the background. So if I'm gonna go to Postman, and now I'm gonna go to port 8181, that is OPA basically. And I look at the data, I can see that the data is pushed to
Can you just make the font bigger?
Oh, I'm sorry. Let's see. Can you see it better now?
Yes.
Okay, so essentially what you see here is this is OPA API. Okay, this is not OPAL. When OPAL client runs, it runs OPA in the background and exposes its port for you. So you can talk directly to OPA. And this is one of the features of OPAL where we don't sit between the application and OPA. So performance of authorization queries is completely the same as running OPA standalone. We don't come between OPA and the application. We push the updates in the background, basically in a different channel. So you can see that the data is already pushed to the OPA instance, and also the policy.
Delete the C2.
Yeah, I'm sorry. And the policy is also pushed, obviously, as a raw file. But yeah, OPA is completely synced. And let's run some queries through OPA and see how it looks like. So essentially, we can see the user table, and also we can ask for an authorization query. Let's look at this query. Basically, what we ask here is if Bob can read a finance object with this ID, basically. That's the query. Now we can push a real-time update through OPAL. For example, let's say it was a billing application and the billing data changed. So we can push an update with OPAL client. Basically, the update looks like we published through a topic called policy data, and we said to OPAL, take the user/bob/location document in OPA and replace it with the data from this URL, basically the API country IS URL. What we did here was replace the user location. And this policy declares that only users logging in from the US can access documents. This is a rule that we entered in the example repo. Now, if we run the same query through OPA again, now we can see that that the result changed. Before the update that was pushed through OPAL, the request was allowed, and now it's not allowed. So this is a very quick example of how you can push updates via OPAL to your OPA agents. Obviously, I showed you how to publish through the OPAL CLI, but OPAL also comes with a REST API that you can integrate to your application. So you can just simply, in your backend, for example, if some object changes state, you can just call a REST API and say, I want to update my OPA agents, only some agents, because OPAL can use topics to shard between agents and, for example, support various multi-tenancy use cases. But basically say, I want this set of agents to have new data. Let's push this update through this API.
It's important to emphasize here that you're not sending the data directly to OPAL. You're telling and to the clients, you're telling it, hey, there's an update. That update sits in this API server or at this database or at this third-party service. And you're telling it, go fetch the data yourself. This also saves on heavy queries being pushed through the live channel, and also enables every client to fetch the data at its own time, kind of distributing the pressure across the network.
Mm-hmm.
So when is a good point? I have some, just to understand all the components, when is a good point to ask a question?
Now is a great point.
So I'm just trying to understand the kind of break down everything we just saw. So we have OPAL server, we have OPAL client that talks to the OPAL server, and then we have the OPAL agent that is kind of a sidecar for the OPA agent.
So so the OPAL client is part of the same sidecar, usually would be part of the same sidecar as the OPA agent. They would be living side by side next to the microservice that you're offering authorization to. And the OPAL client talks with the OPA instance through its regular API. The OPAL client, maybe I'll show a quick slide on that.
So what was the command line tool we used?
So both the OPAL server and OPAL client have a CLI capability, and it includes both the commands to operate them. So you can just use them to send command to themselves instead of having a separate.
In that case, we just reuse the client as a command line to communicate with the server and tell the server to tell the clients to get an update from an API.
That's correct.
So just to make sure I'm understanding the flow here. That makes sense. So
so this is kind of like the overall architecture. So you've got the OPAL server, you have your application or microservices, and you have the OPA agent and the OPAL client sitting next to each other. The OPAL client subscribes over the WebSocket pub channel to the OPAL server for updates, and the OPAL server monitors updates coming both for policy and data. For policy, it can monitor a Git repository. For data, it can monitor whatever you want, and you can just trigger updates like Asaf showed. Those updates are then propagated to the many OPAL clients that you may have, and they send those into the OPA agent.
So,
yeah, go ahead.
So with this slide as context, I'm trying to understand what we saw now was a command line that happens to be the client, but that doesn't really matter.
Right.
Talk to the server and told it to push a live update. And the live update told the OPAL client to fetch data from a data source and
Right.
feed it to the open policy agent. Is that
Exactly.
accurate?
It's super accurate.
Yes, I'll just mention here that the OPAL client that you saw on the command line is the CLI, not actually the container.
Yeah.
So yeah, through the CLI, and we pushed an update through OPAL server, and we said, go to this API, the country IS API in this case, and fetch the data. But at the same time, we could just, through our backend service, use the REST API instead to push that update.
Yeah. Yeah, that makes sense.
Yeah. So at the same way, we could have, for example, applied sharding, for example. If instead of having all the data pushed into all the OPA agents, you could have said only these specific OPA clients and their adjacent OPA agents should get that data. And then you can split the data and just constantly runs in the background. You can constantly trigger updates and have OPAL sync your OPA agents. So when your application comes in with a query, the OPA agent is already ready. And you can also, another thing that is cool here is that you can have the application also listen in. The application can say, oh, let me know when the OPA agent is ready. Call me back when I can start performing queries. And it can also actively ask the OPA agent with a policy that we have, are you ready to answer my questions?
So is that kind of like a Kubernetes readiness probe?
So there's like health checks that are separate. This is more kind of like a callback for more kind of interactive usage within the application. Like if you actually want your service to be triggered as a result, like a webhook.
Got it.
And also mentioning Kubernetes, OPA also have a Helm chart that you can use to install it very easily.
Yeah, any people in Hood in general in our ecosystem love Kubernetes. So any other Kubernetes features, integrations that we should be aware of?
Yeah, so we have those Helm charts, and we have pre-made Docker images, both with just OPAL and OPAL with OPA. And that's basically it for now, but we are accepting pull requests. Like we already had, so the Helm charts that we have are a contribution by a cool guy named Evgeny. And we're happy to have more people come expand OPAL into the ecosystem.
And obviously, we are continuing to contribute new features to OPAL. So we have a live discussion in our Slack, and if something is missing, we also would love to hear about it and maybe design new features together with the community. Always nice to work with other developers on that. Mm-hmm.
Yeah.
So I always like to kind of get a discussion going about pro cons. When should you use this? Oh, one sec. We have a question. Does OPAL server support multiple policy like Styra does?
Yeah.
Yes, definitely. Everything that you can put in a Git repository, you can sync through OPAL. OPAL essentially exposes something that we call a dynamic bundle, which is very similar to the OPAL bundle shape, but is also geared towards Delta bundles and also to couple multiple files together. So yeah, definitely you can just sync a complete Git repo or only some parts of the repo and sync it through OPAL.
So while you start, maybe expand a little bit more. You talked about OPA bundles, and I know OPA has a way to remotely fetch those bundles that can contain data or policy. So kind of maybe pros and cons, this approach versus that approach. When would I want to use this, or when would bundles would just be enough?
Yeah.
Sure. So basically, OPA bundles are great for the infrastructure layer because the way it works, you set up your bundle server, and then OPA agents are polling that server every couple seconds and see if a new bundle is available. But this is not so great for an application because in an application, a user action can actually change the policy. For example, if I invite you to a Google Doc document, The moment I press the invite or the share sheet and I assign you a new role, you expect to have immediately an access to the document. But if you run with the bundle server, it won't work because OPA will wait for the next time it needs to pull a new bundle. And in the meanwhile, the user will not have access. So bundles with OPA are great for the infrastructure layer when the policy changes as part of the infrastructure CI/CD pipeline, but not for applications where you need real-time data updates.
You can always stretch OPA to that layer, but at some point it becomes painful. That's where we decided that we need to add something on top. We started building our solution almost exclusively on OPA, and we started to feel the pain there and the pace of updates that we need to face, and also the amount of data. So I would say if you need just to use authorization for the infrastructure level, just for Kubernetes, and you have a limited data set, you don't have a lot of data or a lot of sources of data, you could probably make do with just OPA. But if you're taking this to the application level, or you want to provide infrastructure that will support application developers, that's where you will start feeling some pains there. Also, if you have multiple data sources, what you'll end up doing, probably, if you're just working with OPA, is writing something like OPAL. You'll end up writing code on your own that either fetches data as part of the OPA query when you're running the request itself, or in the background and pushing it into OPA, which is what OPAL does. And it's important to understand that you can mix and match. You can have, because OPAL doesn't abstract OPA for you. You can continue working with OPA as before, just as is and directly, but it enables you to do more things in the background. So you can enjoy both working with OPA directly for the simple stuff and have OPAL kind of do the heavy lifting for more complex.
And it's also great to mention here that the way we model OPAL is very similar to how Netflix built their authorization with OPA. So essentially what they did there is use the OPA agents to evaluate their policy, and they actually expose some kind of UI, which they don't show in their talk, but we can link it after the session. But essentially they push updates through their aggregation and updates layer that they build. And they also aggregate multiple data sources through that aggregation layer. OPAL is essentially an open source implementation of the same concept. And we were very inspired by their implementation when we thought about OPAL.
Right.
Yeah, if you'll send me the link, I'll add it to the description on YouTube, so it's available for everyone.
Yeah, definitely. We'll do so after the talk.
I see we have some more questions in the chat. Are you guys planning to implement shared policies across multiple OPA?
Shared policies across multiple OPAs. So I think it basically will work now. I don't think we need to change anything. So the idea here in the end, Asaf, correct me if I'm wrong, but in the end, what we have is you are able to say, I have a Git repository. It can hold multiple bundles, unpacked, but bundles essentially, of both data and policy. And you can tell OPAL, take the policies from there and shove it into different places within different OPA instances. So you can mix and match policies as much as you like. There's actually no limit here. And on top of that, if you want to go, and in addition to what OPAL does, go and manually shove more policies into OPA, you can do that too. There's, again, as I said before, there's no limitation on how you use OPA when you're using OPAL. Aside from if you specifically try and override what you asked OPAL to write for you.
Yeah. So Or is correct. Essentially, we expose the OPA policy as topics, pub subtopics. So you can, in your repository, have one directory for all the common OPA policies that are shared between all your agents. But let's say you have a multi-tenant application, you want some policies only for specific tenants. So you can have a tenants directory and inside the directory for each tenant. And then you can subscribe to that directory for each specific agent. So each OPAL client goes up with a list of policy topics, essentially, that it subscribes to. So you can have a different configuration for each OPAL client, and the same OPAL server can serve these policy for all the agents. So each OPAL client can decide what kind of policy it needs through subscriptions, and the OPAL server can serve everything in any model that you like.
All right, another question from the chat. Which analytics tool does OPA server support for the decision log? If I understand correctly, the server doesn't get the OPA decision logs, right? Or if I understand the architecture correctly, or is that something that you plan to also stream the decision logs for the server for like a single pane of glass?
So that's something that we're looking at. That's not our main focus currently. It's more something that the guys at Styra with Styra Desk focus on, and we're trying to not to step on anyone's toes. But it's something that can possibly be available in the OPAL server as well. In the end of the day, the decision logs themselves are something that OPA produces, and not OPAL. And you can have whichever solution you want to stream those outside. You can use Styra Does, you can use something homebrew, and maybe down the road we'll also offer something there. We're also constantly talking to the guys at Styra and OPA to co-evolve the products and try to see that we put our efforts where they're best put.
All right, very cool. And again, if there's more questions, feel free to drop them in the chat. So let me just summarize what I'm hearing so far. Essentially, it's a complementary tool to OPA that allows you to do kind of real-time updates and solve challenges that are present in the application layer versus the infrastructure layer. Is there any, I'm trying to think on other kind of operational considerations that might occur, like what happens if the network goes down, especially, with security, how would it behave in a sense?
Yeah, so there are a lot of parts that, we described this kind of very quickly, but we've really designed a rather complex solution here, and we thought of a lot of pain points that you need to tackle for this to work correctly. So the positive side for that is most people don't have to worry about it. They can just use OPAL and know that we've kind of covered this for them. But let's try and highlight some of those friction points. One of them is network congestion, or the net connection is being severed. So the idea is, because we're using a live channel, we can constantly send diffs to the OPAL clients. So they're constantly subscribing to more updates, but they're tracking if they lose the connection. And if they lose the connection, they're aware of it. It's not like it happens in the background and they forget about it. So when that happens, they essentially are aware that they are no longer updated, and they try to reestablish the connection and refetch everything from ground zero as if they have nothing. In the future, we'll also have some diff mechanism there, so they can say, okay, this is where I lost you, and bridge the gap. But for now, if the connection is lost, the OPAL client will understand that it has been disconnected and reestablish the entire update sequence to that point. In terms of if, in general, the network, like if your OPAL server is no longer available, your OPA instances can still work. In general, if the OPAL client and OPAL server are down, the OPA instance itself can still be functional, and you can still send queries to it. The only thing is that they might be up to date, and you can use OPAL to mark you can essentially query OPA to know when was the last update that it got, and you can query OPAL to know if there are additional updates that are incoming. So you can kind of choose what's the right solution for your application at that point. You can say, okay, I've lost connection and I'm unable to retrieve updates, and say, okay, I need to throw an exception here and wait until the OPAL is back online. Or you can say, okay, I'll continue working as usual until the updates start streaming back in. And obviously, anything in the middle, it's your code. You do what works for you.
Makes a lot of sense. So essentially, what I'm hearing is that you have customized behavior, how to behave on failure, and one of the options that people usually like is, keep less known good config until there's another way. What about things like observability? Like if OPA disconnects, is there like a metric I can watch or anything like that?
Yeah, so both the client and the server provide a health check route, literally /health check, which you can query and use as part of your Kubernetes cluster deployment or pod deployment. And in addition, they generate structured logs that you can configure, and you can streamline with something like FluentD or drive metrics out of it and push it into Prometheus or something else. And we're looking to add more metrics into the health checks themselves. Instead of them being just binary, I'm alive or not, they will also include some additional data. So you can know, oh, this is the last version of update that it's got. This is it's now in the transaction of mid update, et cetera, et cetera. Asaf, do you have something to add on that?
I think we pretty much covered it all.
Yay. We can also do a application demo, kind of show how an application using OPAL kind of feels like, if you want.
Yeah, I think it would be great, especially since it is geared towards the application layer. I think it'd be helpful to kind of see how it is used, so to kind of help people understand when they need to use it.
Sure.
Go ahead.
Let's look at it. Can you see my screen?
Yes.
Yes.
So what we see here is a demo application, a to-do app application that uses our Authorizon SaaS to manage the permissions for that application. And it uses OPAL in the background to push updates in real time. I'll just mention that when you use the SaaS, you actually are not aware of OPA or OPAL. It all runs in the background seamlessly, and you just like integrate with a simple SDK. So we can break down the update once we see it and see that it works through OPAL. So what we see here is a very simple to-do application where you can add to-dos, and you can delete them, and you can check and uncheck them. This application is a front-end application in React that uses a Python backend that exposes a REST API to save all the state in a PostgreSDB, very, very standard configuration. So this application used the Authorizon SDK to expose something that we call enforcement points, essentially the points that you want to enforce permissions on. Here in the SaaS, you can see that we have several roles in RBAC configuration where we have tasks and board. Essentially, each task here is a separate task resource, and a board essentially holds several tasks together, and you can add several boards if you want. And each one exposes different enforcement points, different actions, essentially. And we assign them to the roles. Essentially, the admin has all the permissions, and the viewer has some permissions, read permissions. So the cool thing is that if I want to delete this task, I can do it. The API returns a standard response and allows the request and delete everything from the DB. But now I will change the configuration and save it in our SaaS. And at the point that I save it, OPAL will push an update in the background to the OPA agent. And now the API throws 403 exception, and it seamlessly works. Another thing to mention here is that the configuration that you see here for RBAC is essentially in the background a Rego policy with Rego code and data, and everything is flexible. So you can replace your entire policy with something like attribute-based access control, and nothing in your application needs to change. Only the management layer changes the code, and OPAL will push your new policy to the agent. So the application stays the same.
So to clarify what Asaf said here, so we've built a UI that generates Rego code and uses OPAL to push it to the OPA instances. So this is kind of like an extra dynamic layer on top of OPA. If you want to be able to change your policy in real time, which is something that happens. For example, your product manager or salesperson want to do something on top of the application, you want to enable them to do it without you having to do it. And OPAL just does all the heavy lifting here. We just push an update into a repo, and it propagates all the way down.
And I think the cool thing about this is that Authorizon is all about complete experiences. So you can always drop down to code and you can edit the rego and you can decide you want a very custom policy. But we also have the templates where you can just choose the RBAC template or ABAC template and just use a standard kind of policy, and you can have embedded API UI interfaces where you can have complete experiences that are permission related on top of the infrastructure that we built. So essentially you have a complete user management screen where you can edit the roles, and I can decide that this email is now a viewer and it has no edit access to this board. Okay, and now if I log in with this user, and we work with any identity provider. Essentially here we use Auth0. And I can see that now when I log in, I can see the list, but if I'll try to add something, I cannot. But this user has the permissions to change stuff. And I can always change it back in real time. It's very easy. So you don't have to know all the DevOpsy stuff to deploy OPAL if you don't want to. But we did want to expose this kind of capability as open source, so everybody that wants to build on their own can essentially do so.
Very cool. So let's start wrapping up. I want to do like a pop quiz to myself, see if I can reiterate kind of what you said about what OPAL does. So OPAL kind of gives you a control plane for real-time updates for config and data to kind of, and with the goal of enabling OPA usage in an application use case where there's a high degree of changes, right? So you have that PubSub mechanism to kind of facilitate changes very quickly to enable OPA to be used at an application layer, kind of opening that use case and not just the infrastructure layer.
Right.
So in that case, OPA is really good decoupling, policy from the microservices. Now you can also open that up to give a kind of a unified authorization model also on the application layer.
Right, and you can use the same configuration, same OPA instances, even if you like, and you can mix and match according to where you need more real-time updates and where you can keep it simple, and you can grow and deploy this gradually. Yeah, so you got it completely right.
Very cool. So, sorry, go ahead.
Yeah, I'll just say that OPAL is essentially about data aggregation from multiple sources, authorization data, and real-time updates. And it was designed so it's not tightly coupled to OPA. It currently only supports OPA as a policy store, but it will support other policy stores in the future. So for example, we're very interested in other policy engines such as Keto with Ori and stuff like that. And we want to essentially bridge between different policy stores so that if you start with one and you want to migrate to the other and you want to migrate back and you want to work with them together, essentially you can. That's basically the vision for OPAL.
On that, do you plan to abstract the policy language?
No, not at this point, but you can essentially have them, I don't want to kind of spoil a lot of things that we kind of have for down the road, but you can essentially have them working with one another if you plan for it. You won't be able to switch them out of the box, but you'll be able to have them work alongside one another and use one another as kind of data sources or additional places to redirect the queries.
Got it. That makes sense. So yeah, anything more you want to add, Asaf? Sorry, I cut you in the middle.
No, it's cool.
All right. So people who want to read more, interested, where should they go? Where's the code? Show me the code. Where's actually? I learned the hard way that the docs are more important than the code for most people.
Yeah. So we try to keep them together. We currently have everything on GitHub, so you can go to github.com/authorizon. That's Authorizon as one word /OPAL. If you'll Google Authorizon OPAL, you'll also find it. And it's also easy to find on opal.ac, which is our basic documentation website, and with a clear description, a quick video. So you can probably start from there. That would lead you to our GitHub repository. And also we have a small Slack community that you're welcome to join and ask myself and Asaf questions directly.
How do you join the Slack?
You'll find a link for it on opal.ac.
Got it. And I assume someone want to get in touch with you guys. What's the best way? Twitter or Slack or GitHub?
Yeah, so you can find us on Twitter. You can ask questions on our GitHub. We use both GitHub discussions and GitHub issues. So if you want like a feature or you have a problem with something that you just want to report, GitHub issues or GitHub discussions is the way to go. If you want to ask more in-depth questions, you can find us either in our Slack community. You can also find us in OPA's Slack community. And yeah, we're really easygoing. So just feel free to just throw things at us. We'd love to talk to guys and gals that are interested in authorization. So yeah, just look us up and feel free to shoot us questions.
All right, yeah, it's great to see more projects, open source projects in this OPA ecosystem. I know people really love OPA, and I think that use case to bring it to the application layer makes a lot of sense. With that, I don't think we have more questions in the chat. If there are, now is a good time to place in your final questions. We'll start wrapping up. Thank you, Or and Asaf, for joining me today. Any last words you want to add?
No, it was fun. Really, thank you for having us. I hope we'll get to do more stuff in the future, and I hope people will try OPAL out and maybe contribute some code to it. We're really happy to welcome anyone.
Did the example Asaf added, is that on GitHub too? Like if someone just want to go ahead and try it?
Yes, so the example repo is also under the Authorizon organization on GitHub, but basically go to the OPAL repo and we have the entire thing as a document, as a quick start guide. You can just follow along the instructions and everything is very explained in a lot of detail, essentially. So you can just go to our repo and you'll find everything there, all the links.
We try to put a lot of effort into the documentation, but also we're welcome to feedback if we haven't done enough work on the documentation.
If you don't like some document or you think something is missing or you have any feedback on the code or the docs, just talk to us. We are very responsive.
All right, very cool. So with that, we'll wrap up for today. We'll see everybody in 2 weeks. We'll talk about rate limiting and Envoy, kind of decipher what's going on there. Sometimes it can be a bit cryptic. Thank you, everybody, for joining today. Thank you, Or. Thank you, Asaf. And we'll see you all in 2 weeks. Bye, everyone.
Thank you. Bye.
Bye-bye.